Yesterday we talked about inequalities in a single triangle, that if I knew something about sides, I could rank the angles, or if I knew something about angles, I could rank the sides. Today we're going to talk about inequalities in two triangles and making comparisons between the two triangles. Our first theorem is side angle side inequality. We had a side angle side congruence earlier this year, and that said if a side angle and side perfectly match in two triangles, then the two triangles are perfectly congruent and all of their stuff matches. This one says, in two triangles, if I know two sides match, and I know the angle between them does not match, then the side that is across from the bigger angle will be bigger. Okay, so it says if two sides match, but the angle between them does not match. So one of the angles is bigger than the other one, and I use the two marks to denote bigger than a single mark. Then the sides across from those angles will not be the same. And the bigger angle will make the bigger side. A visual idea of this is to think about having like two sticks on a hinge. Okay? The sticks are not changing their length, but if it's on a hinge, I can open and close it up and change the size of that angle. Changing the size of that angle would change the required length to be able to connect the ends. The bigger the angle, the longer the connection. If I reduce down that angle, it would be closer to connecting. Okay? And that's what this says. The sides aren't changing, the sides are the same. But if I change that angle between and open and close the hinge, that's going to change the length of that third side. The bigger the angle, the bigger the side that would be required to close it up. Okay? So side angle side inequality, we know two sides match and we know an angle does not match. That will mean that a side doesn't match as well. Bigger angle makes bigger side. Our second theorem for today is the side inequality. Once again, we had a congruence for this before, but now we're saying that they're not congruent. It says, if in two triangles I know that two sides are the same, but the third side is not the same, then the angle across from the bigger side will be bigger than the angle across from the smaller side. This is really kind of the converse to the other one. In side angle side, I know information about a side angle side and I conclude something about the third side. And this one, I know information about all three sides, and I'm concluding something about the angle. It can be very tricky for students to determine which one they're using, and in some of your problems, it will just ask you to draw a conclusion greater than, less than, or equal to. In some of the problems, it will ask you to draw a conclusion and tell which one of these two things you are using. The name is based on the given information. So if you are given information about a side angle side, then that's the theorem you're using. If you are given information about all three sides, then that's the theorem you're using. Okay? The name is based on what you start with, not what you conclude. Okay? So let's do some examples.
Are we going back to two common proofs?
We are not doing proofs tonight.
Yes. Thank you.
You guys kill me with your excitement about that. Proofs are not that bad.
Indirect proofs are all
Indirect proofs are worse.
I love indirect proofs because it is literally every day of my life that I make bad assumptions and end up having to redirect myself, and that's exactly what an indirect proof does.
Yeah, but
You make an assumption and then you're like, oops, this didn't work
you
out.
don't get graded on your
So-
process through it, though.
Oh, but it's life, and I think life is more important than grades. And I'm a teacher, and I think life is more important than grades. I think grades are really important, but I think life is more important than grades.
So you're saying we should just leave Life is more important.
Yeah, we gotta
Life
live.
is more important than grades.
We gotta live it.
So
You know, part of my goal in teaching is not to just teach you math. It is to teach you math because that's my job and that's what I chose to go into. But in the end, I know that when you are, 35, 40 years old, you will probably remember very little of what I taught you about math. But I hope that you will remember some things I taught you about life and life skills.
Yep, life is better than
So,
Amen.
um,
Learn that.
all right, in this one, we want to state which theorem we would apply, and then we want to draw a conclusion.
Time.
So sometimes it's easier to state the theorem before you draw a conclusion because the theorem is based on only what you're given. So once you start putting other stuff into there, it can get a little bit confusing about what we started with and what we did ourselves. So based exactly on what we're given, what are we given? Side. We're given information about all three sides. Now using that information, what can we conclude in here? Angle A is bigger than angle D. Across from the bigger side will be a bigger angle. So since 15 is bigger than 14, A is bigger than D. Okay, first, let's say which theorem we would apply to this problem.
Side angle side.
Side angle side, because that's what we're given, is information about two sides and an angle. Now, using that information, what can we conclude?
P is bigger than it.
Little p is bigger than little l, or we could say NO is bigger than JK. The sides across from those angles will be different sizes, and the bigger angle makes the bigger side.
This is actually a problem. So it's easier to get these.
All right, angle 1 is greater than angle 2. We need to know 3 things before we can apply one of these theorems, because either one of them needs 3 things, 3 sides or a side and angle in the side. So what else do I know?
TV is congruent to TP.
Or reflexive, right? These share sides, the 2 triangles have something in common there. And then if I mark what I'm given, angle 1 is bigger than angle 2. Which theorem would we apply? Side angle side, because that's what we're given. And what would we conclude?
TR is bigger than TS.
TR is bigger than TS. Okay. And this would be a problem where we have to use the 2 letters. We can't use the little letters because both of those sides would be called little letter v. We can't say little v is bigger than little v. That doesn't really give us any help. So bigger angle makes bigger side. All right. Information is marked about 2 different things in the triangle, so it's a third thing.
NG is congruent to NG.
And G is congruent to itself. So which theorem would we apply here?
Side angle side.
Side angle side, because that's what we know. We know the sides are congruent because they're both 7s. We know the angles, and we know that third side. And what would we conclude here? We could say UG is congruent to GO. Or really, we could say the entire triangles are congruent, because here we have a side angle side congruent. Everything is equal, which means that everything about these triangles would really be equal. Some of your problems will have a blank to fill in about two pieces of information, and it will say you could do a less than, a greater than, or an equal to. So equal to is still an option based on congruent triangles. Okay. 1 and 2 are just marking what those angles are, not anything about them. So we don't know that like 2 is bigger than 1. That's not saying it's 2 degrees and 1 degree. That's just the names of the angles there. So what's a third thing we can know?
That the top and the bottom are congruent.
We know the top and the bottom are congruent. What else do we know?
The middle one.
The middle one is congruent to itself. And we know 5 and 6 are not the same size. So which theorem would be applied to this problem? Side, 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 because we know stuff about all 3 sides of the triangles. And what would we conclude?
That angle 2 is smaller than angle 1.
Angle 2 is smaller than angle 1, or angle 1 is bigger than angle 2. Across from a 6 is bigger than across from a 5. One final example. All right. A lot of students struggle with this problem because they think there is a mistake here. Because 92 is bigger than 88, but the numbers across from them are marked as being the same. Okay? We have to be careful that we're actually applying one of the 2 theorems. So we need to either know a side angle side or a side 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 to be able to make these types of conclusions. So if we mark what we know so far, we know 18 is the same as 18. We know our reflexive. So we do know 2 sides and an angle, but that angle is not the angle we care about. Side angle side needs to know about the angle that is between the sides. So we need to know about those angles that are over by G. Okay? We don't know about those. We do know that the 2 sides that are marked as 18 are the same. Which means what about this picture? The whole thing is an isosceles triangle. Which means what will be true? Angle F will be the same as angle D. The whole triangle FDG has 2 sides that are the same, means 2 angles should be the same. Now, we know that the angles of a triangle add up to 180. So in each triangle, we've used some amount that's the same for that F and D. We don't know how big it is. We could pretend. We could plug in some numbers if we wanted and say like they're both 30. But we don't really know exactly what they are. And then we know these other angles, 88 and 92. There's no way to find out exactly how big the 2 angles over by G are. But we can know which one is bigger. Which one is going to have to be the bigger angle over there?
FGE.
FGE will have to be the bigger angle because a triangle must add up to 180. And in the top triangle, so far I've only used up 88 and whatever that other one is. And in the bottom one I've used up 92 and whatever that other one is. So in the top one so far we've used up less. We've used 4 less degrees. So that means that top angle over by G should be 4 degrees larger than the bottom angle to balance out so each triangle has 180. Questions on that?
That one we were trying to find, which one was bigger?
Well, now we know in each triangle a side, angle, and side. So now we can draw a conclusion based on side, angle, side that what?
FB is larger than ED.
FE is larger than ED. Across from the bigger angle, there is a bigger side.
And that's what we're trying to find.
And that's the conclusion we're trying to draw. Okay? So make sure that you're not just looking at, oh, I have two sides and an angle, but that it is the appropriate angle. The angle must be the angle that's connecting the sides. Okay? Questions? Your homework is from 6-5. It is a short assignment. There are only 9 questions, and none of the questions are proofs.